Good morning. Earlier, we discussed the components of the air distribution system. In this part, you'll learn how to properly install the system, the ducts, and the rest of the installation components, as well as how to carry out measurements and adjust the entire ventilation system in your home. Ventilation in practice. We have the design ready, the products are known, so now it's time for installation. When it comes to installation, the project for the heat recovery system includes the execution guidelines. Just as a reminder, right, the minimum length of ducts from the distribution box to the plenum box should not be less than 3 meters. The minimum length of Sonodeck duct sections should not be less than 1.5 meters. The location of the diffusers from the partition should be from about 60 centimeters up to 1 meter. Remember to carefully make the wall penetrations for the air intake or exhaust, leaving enough space for additional insulation to protect against thermal bridges. It is recommended that the diameter of the intake grill be at least one size larger than the duct coming into it. The temperature in the room where the heat recovery unit and the ducts supplying the intake or exhaust and the distribution boxes are located should not be lower than +5 degrees and at most +50 degrees, or they should be properly insulated. Remember to install the unit in accordance with the manufacturer's guidelines and the user manual. See the technical description. We not recommend connecting the heat recovery system with other systems, such as air conditioning. It is not recommended to connect a kitchen hood to the heat recovery system installation. Use the appropriate thickness of insulation on the ducts, depending on the ambient temperature. See the table in the project. Remember to regularly check the cleanliness of the filters and replace them when necessary. Remember to adjust the installation according to the project. When installing underfloor heating, be careful not to puncture the ventilation ducts. If you're unsure about any point or want some advice, the technical support department, whether it's Peflex or Recunit, is always there to help you. When it comes to the proper installation of ventilation ducts, especially in attics, as mentioned earlier, the entire system, the pipes, everything must be placed under the layer of insulation. So we need to pull out our pipes, our ducts, under the insulation so as not to go into the insulation itself, especially the attic insulation, because that's where we can create thermal bridges, which means, among other things, heat loss when transferring air between the house and the ventilation unit, and in the other direction between the heat recovery unit and the supply system. When it comes to the length of the ducts, if the design specifies a section of about 12 meters, but during installation on site it turns out that the system needs to be longer than those 12 meters, we recommend adding another duct in such cases to reduce resistance in the system. This ensures the correct amount of air at the supply or exhaust points. On the other hand, if we're dealing with a situation where the sections are shorter, we can always bend the pipe into arcs or elbows to introduce additional local resistance. This way, these local resistances add more pascals of resistance to the system so that the distribution system is at least similar in terms of hydraulic resistance on each section, on each branch from the manifold. So in such a case, you can use this bending or curving. High rooms with high ceilings. It looks really nice. Is it possible to do this during the installation stage? We can install it, by bringing in a big ladder, setting up scaffolding, or even using a scissor lift as scaffolding. But when we need to service such a point or check the cleanliness of the ducts, or even make adjustments once the building is already equipped with or finished with flooring and the furniture is in place where we no longer have the option to bring in these elements like scaffolding, it's better to avoid this kind of solution. In such cases, we suggest, for example, using long-range nozzles installed somewhere at about arm's height, where you can reach the spot and make adjustments just by using a small ladder or a stool. So let's avoid installing supply or exhaust points in hard-to-reach places. When it comes to rooms with slanted ceilings, like for example a storage space under the stairs or a walk-in closet with slope ceilings, remember that you don't always have to install supply or exhaust vents on the ceiling. We can use the sidewall where we can access the room through that wall either to supply air or to extract it. In terms of noise reduction, when using flexible ducts, the minimum length of flexible duct needed to dampen noise between the ventilation unit, the heat recovery unit, and the supply or exhaust manifold. We recommend a distance of at least, or we suggest at least 1.5 meters of insulated flexible duct to use it as a silencer. However, when it comes to rigid ducts like steel Spiro pipes or the Peflex EPS system, we recommend using silencers, either flexible or rigid silencers. This is to ensure proper sound attenuation. Adapters, bypasses, right? Sometimes we need to bypass our ventilation system or other installations like water, heating, or electricity, so we can use bypass fittings. For example, we have bypasses available for a 75 millimeters pipe to 50 millimeters pipes, or a 90 millimeters pipe using a 75 millimeters pipe. But here we have a simple bit of math. 2 75 millimeters ducts equal 5 50 millimeters ducts. Remember, earlier we discussed the capacity of the ducts and the maximum capacity, right? That we can use at the appropriate speed. So, to achieve the same capacity, 60 meters from 2 75 millimeter ducts, here we need to use 5 50 millimeter ducts, meaning 5 times 12 meters, which also gives us exactly 60 meters. Other elements that make the installer's life easier. The installation knife, the one for cutting pipes, back in the days when it didn't exist yet. I remember how much longer it used to take, right? You had to do the installation just to properly cut the pipe to trim it. So, this kind of knife sped up installation time by about 20 to 30%, at least when it comes to cutting pipes. On the other hand, we also have other components at our disposal, like couplings with a click connection, or this manifold that we can design ourselves, so these kinds of elements also make installation on a project easier and faster. Other elements include plastic brackets, which we can use to mount the installation on the ceiling, or perforated tapes, which we can use to secure the ducts to the floor. The EPS system. We can also use these pipes or ducts, for example, to pass through a wall for installing an air intake or exhaust outlet. And what benefits do we get from using the EPS system? We immediately have a pipe that is already insulated, self-supporting insulation, right? The EPS itself. We also have a built-in reducer because the internal diameter is 200. The external diameter is 250, so as mentioned earlier, the intake grill must be at least one size larger than the duct supplying air to it. So here, as I said, the EPS pipe solves two problems: the thermal bridge in the wall and also the reduction for installing the intake or exhaust grill. Just to remind you once again, right? How can we actually install the EPS pipe, that is, using a connecting sleeve, right? We can connect the intake grill to the EPS duct. If someone wants or needs to use additional insulation, here we present methods for calculating the length and the amount of insulation that needs to be cut from the roll. So, for round ducts, we use the formula pi times the diameter plus 2 times the thickness of the insulation plus an extra allowance of about 2 or 3 centimeters. And for rectangular ducts, 2 times the length of side A plus 2 times the length of side B plus 8 times the thickness of the insulation plus an extra allowance of about 2 or 3 centimeters for trimming. Now we move on to the topic of measurements, specifically measurements at supply or exhaust points, which basically means checking whether we have the correct amount of air at the right place according to the design. For this purpose, we definitely use anemometers. Like the one here, for example, right? The one I'm holding in my hand, or the one shown here on the slide. The difference is that the one I have in my hand right now is a newer model. It's still called the Testo 417, but it has Bluetooth connectivity with your phone, so you can check the results more easily as well. However, it's worth using Testo anemometers that are equipped with the proper tubes, because these tubes average out the amount of air flowing through, which translates into the displayed result as cubic meters of air per hour at a given point. So, by using anemometers, testo-anemometers among them, you need to carry out the entire process of measuring and adjusting the system. Once you have accurately measured the flow values, it may turn out that at a given point there is either too much or too little air. In places where there is too little air, there's nothing we can do. However, we do have the ability to adjust the amount of air at those points where there is too much of it. And for this purpose, it's best to use balancing dampers, which restrict the airflow at those points where there's too much air, so that the throttled air can be redirected to the areas where there isn't enough. This is a system of communicating vessels, a kind of manifold system. So, in order to achieve the desired value in a place where there isn't enough air, we have to throttle it in another place where there's too much, using, for example, such a damper. In the next part, I'll discuss the topic of properly selecting a heat recovery unit, capacity and available pressure.